Okay, today we are going to do what is a homogeneous differential equation. Okay, so when we look at this word homo, what is the meaning of homo means? Homo means is same, the same. Okay, so how to know whether it's a homogeneous equation or not? Look at this. Okay, look at this one. X squared, the square here, the degree is 2, and then here the degree is 1. That means overall here the degree is 3, isn't it? Then how about this one? This is degree of 3. This one also degree 3, isn't it? So that means overall the degree is 3. Degree is 3. The degree is 3. Okay, this one also, okay, you see this one, the top one, the degree is 3, the bottom one, the degree also 3. So it's just like a power 3 over a power 3. So the answer is a power 0. That's why the degree is 0. Okay, so look at this one. This one, the degree is 3, but this one, the degree is 2. Okay, so overall what is the degree? We don't know, because here is 3, here is 2. Okay, like this one, the degree is 3. Like this one you see, you look at the y, the power is 1, the x is 1. That means a power 0 over a power 0. So sorry, a power 1 over a power 1. So that the overall the degree is 0. Okay, now then we look at this one. This one, the degree is 1. Degree is 1. So this one degree is 1, 1. So overall here the degree is 1, isn't it? And then this one, the degree is 0, like here. Sorry. Here. The degree is 0. Okay. So here the degree is 1. This one also the degree is 1. That means you see, overall here, the overall, the degree here is 1. The degree here also 1. That's why same degree, we call it homogeneous. Same. The degree is the same. Okay, look at this one. This one, the degree is 2. Okay. This one, the degree is 2. This one also the degree is 2. And then this one, the degree is 2. That means overall the left hand side, the degree is 2. And then the right hand side also the degree is 2. That's why it's homogeneous. Okay, there you see the degree is 2. 2 is a constant, no degree, x power 0. And then here is x power 1, y power 1, so the degree is 2. Okay, so this is homogeneous. Okay, look at this one. This one, power 1, a power 0 over a power 0. A power 1, a power 1. Overall is a power 0. Okay, so this side, the degree is 0. How about here? You see, this one, the degree is 2. This one also degree 2. That means just like a power of 2. Over here also, degree is 2, degree is 2. So here also a power 2. So overall, the a is power 0. So a power 0, homogeneous. Okay, now look at this one, dy dx. Again, this one is a power 1 over a power 1. That means the power is degree is 0 overall, the left hand side. But here you see, this one the degree is 2, but this one the degree is 1. So overall what is the degree here? Don't know. Here the degree is 2. Okay, here the degree is 2, but what happened to this one? What is the degree here? Don't know. That's why this is not homogeneous. Okay, so that's how we look for homogeneous. Okay, how about this one, dy dx? A power 1 over a power 1. Overall the degree is 0. Here the degree is 3. The degree is 3. So this is a3 over here also a3. That means it's a0. So it's homogeneous. Here the degree is 0. Same like here. But here the degree is 3, a power 3, but here the power is 2. So here is a power 1, a power 0, but here is a power 1. So this is not homogeneous. Okay, so even like this, let's say I give you x dy dx. Let's say I give you this one, this is square root x squared plus 4y squared. Look at this one, is it homogeneous? Okay, this one the degree is 1, a power 1. This one is a power 0 because a1 over a1. Then here is a2 power degree 2. This one also a2, you see. Then square root become a1, isn't it? So this side also a1, therefore this is homogeneous. That is how we look for homogeneous differential equation. So now I give you an example. You see, I give you one example first. Okay, you look at this example. Okay, here you look at this one. X squared plus y squared dy dx equal to xy. Okay, this one, okay, first of all, we try to see whether I can solve this using different separable variable or not, which we have learned before that. So if I try to use separable variable, I have this. You see, I should have this, then this is dy equal to xy dx. Am I right? So I have to separate this one first for separable variable. Of course, separable variable is the easiest one. So every time you try with separable variable. So now y is here, the x is here. Can you bring the y here and can you bring the x here? What I mean is, okay, this y we can bring over like that. This y I can bring over it like that. Then this is, and then the x I leave it here. So very good, the x with the x. This one y with the y with the, but the problem is this x, can I bring it over here? It's impossible. We cannot do that. This x, can you bring it over here? Unless you bring it like that. You see, unless you bring it like that. You have to bring it like that, yes or no? But once you do it like this, what happened to the y? Can you bring the y over here? Cannot. So this is non-separable. This is non-separable. So if this is non-separable, whatever we have learned before that, we cannot use. We cannot use already. So you must think of other method. Of course, it's not you think. Somebody have already taught this. They have already found this, and then we just learn. So what we do every time, this is homogeneous. Okay, first of all, this is homogeneous. How do I know this is homogeneous? You check the power. This one, the power is 2, power is 2. This one, the power is 0. Here, the power also 2. So here is a squared, this one also a squared. So it's homogeneous. So if homogeneous, you remember, you always substitute with this. Always, every time. Okay, or you can put y equal to ux. It's up to you. Sometimes they ask you to use u, or you can use vx. Okay, so what we do here for homogeneous case only, so you just change all the y into vx. So you see how I change it. X squared plus this is vx, v squared x squared. Then here I change the y into vx. Here also I change the y into vx. So what I have to do here, I have to differentiate this. So when I differentiate this, here you see I have 2 persons here, so they are going to toilet, they have to take turns. So v, I differentiate the x, I get 1. Then x, I differentiate it, dv dx, then here I get this. Okay, then what I do, this x squared, you know, I can cancel. Then after that, this one I have this, I bring this one over, I get this. Okay, this one you know how to solve. And then I have this. Okay, after that you simplify this side, you get this. Okay, so you see from this one, this is homogeneous, then you substitute this, you see now it has already become separable. Sure, it will become separable variables. Homogeneous, substitute this, then you simplify everything, it will become separable variable. So once you get separable variable, we try to separate. Now it's v and x, so dv dx. So all the v, all this v you have to bring over here, all the x we bring over there. Then this one you see the numerator, we can break it, you can separate them like that. So v negative 3, this is v negative 1, so like this. Then after that you just integrate, this part you just integrate. So v negative 2 over negative 2 ln v, then this one you integrate. After that you just simplify. You see how I simplify here. Okay, you just simplify. Then after that, what we do here, you have to change back the v to become y and x, because our problem is our differential equation is in terms of y and x. So you have to change back the y and x. So the v is y upon x. So you just substitute. Then after that you simplify. Then you will see that you get all this. Okay, you will get all this. You should know how to. So you simplify, you get this one. So finally you get this answer. Where this one is a constant, which when we integrate, because we integrate the 0 here, you get a constant. So because with this constant, and then this one, when you bring this one over, is e to the power of c. E to the power of c is a constant because it does not involve with x and y. So it's a constant, so we can write it as a like that. So this is called a general solution. Okay, this one we have learned this before. What is general solution? Because we have a constant, we have a number which we haven't determined the value. So this is a general one. Okay? So you go through this one first.